Greetings to you all, my people, colleagues, ladies and gents. I hope you are all good. And in this tutorial, I'm going to take you through three-dimensional trigonometry, whereby I'll be uh, giving you some basic strategy on how to attempt question like this. Okay, so just stay tuned since I am going to start with this question, right? And of course, if you need some further assistance regarding mathematics, physical science, just hit me on my email or my number there above the right corner. Okay, so 4.3 in the figure, alongside A, B, and C are 3 points in the same horizontal plane. D is vertically above B and E is vertically above C. The angle of elevation of E from D is theta degree. F is a point on EC such that FD parallel to CB. BAC equals to alpha, ACB equal to beta, and AC denoted as the beta, as the B meters, right? I hope you can able to see everything here on the diagram, right? So let me take you through this question 4.3.1. You would recall, guys, when you answer any question in three-dimensional trigonometry, we need to use these rules, right? The first one, which is area rule. Number 2, which is the sine rule. Number 3, which is the cosine rule. Then with these two additional trig ratios, here I'm talking about the sine, which is equals to our opposite of our hypotenuse, the cos, which is equals to adjacent over hypotenuse, tan as well, which is equal to opposite over adjacent, right? So lastly, we have this Pythagoras theorem. Okay, so when to use these trig ratios and Pythagoras theorem? If we are given any right-angled triangle, you need to consider this, right? You need to consider this. In order for you to see if you are using trig ratio or Pythagoras theorem, you will see by the given information on your diagram or on the scenario, right? But what I need you to check here is every time when you are using the triangle having 90 degrees, you only go with the trig ratios and Pythagoras theorem, right? You are prohibited to use the right angled triangle here into these rules that you are seeing here, right? You do not use this at all. The triangle that you need to use under area rule, sine rule, cosine rule, make sure that it doesn't have the 90 degrees on it. It is where you will see that you will flow, right? However, let me show you how to answer this 4.3.1. They want us to express DE in terms of DF and theta. So I have to check this DE on my diagram, right? Here's the DE, is the DE, and here is the DF, right? So of course, I am going to use this triangle, right? So I can emphasize the point that in triangle, which is this DEF, look at this triangle, it is having 90 degrees here at F. So this is the right angled triangle, right? Whereby we have to use trig ratios or Pythagoras theorem, right? Because I don't have any side given here, right? I cannot go with the Pythagoras theorem. I will use the trig ratios here. Then I'm going to select the right one that it is corresponding with this 4.3.1. Okay, I need to find what the DE, right? So the DE must come first. And the side, which is the DF and theta, must be the part. So this side must be included as well. Together with the angle must be included. So I need to go and check the trig ratio that will favor this. Remember that this is my adjacent, opposite, and hypotenuse. The one that favors adjacent and hypotenuse is the cos. So I am going to use the cos here. It's going to be the cos of given angle at theta equal to my adjacent as the what? As the df divided by dE. After that, I have to make this d subject of the formula by cross multiplying. dE multiplied by cos of theta is going to give me dE multiplied by cos of theta equal to 1 multiplied by df. It's going to give me df because any number multiplied by 1 is that number. After that, I will divide by cos of theta in order for me to make dE subject of the formula. This and this will cancel out. Then my final answer will be dE equal to df divided by cos of theta. This is how we solve it, guys. 2 marks for you to do this, right? You're going to get 1 mark, then you have 2 marks for this. Done. So let me show you how to solve 4.3.3. 4.3.2, sorry. Hence show that dE it is equal to b sine alpha divided by the sine into alpha plus beta multiplied by cos of alpha, cos of theta. So, ladies and gents, you see that here we are working towards 5 marks, right? So it's not something big, guys. It's not something big. So what I'm going to do, this is just a continuation, right? I have to go and check where there is this dE. dE, still, we're talking about this dE on the first triangle that we're using here in 4.3.1, right? This is the dE. So I have to go and search for another triangle that it is sharing common side with the first triangle. Let me repeat this. Just because I have the triangle already having the dE on it, I have to go and search for another triangle, and that particular triangle, it must be sharing common side with the triangle DEF. Okay, I hope it is clear to you all, right? And I am only having one triangle there, as you can see, which is this ABC, right? This is the triangle that I am having in this given figure, right? So if you have a look here, in this triangle, we don't have the common side, the side that it is common between the first triangle, which is the DEF. But I can do something to link these two triangles, right? What is it that I can do? Just watch here, right? Look at the relationship between this BC and the DF, right? This BF, it is equals to what? To BC, right? You know, these are the properties of what? Of our rectangle, right? Whereby this side it is equals to this side it is equals to this one. So I am going to I'm going to express this CB or BC in terms of the BF, right? So I can able to solve. All right. So now on my first triangle, I have the equation already, which is denoted as the dE equals to dF divided by cos of theta. So I have to go through this green triangle and produce another equation, right? Whereby I will solve these two equations simultaneously to find this dE. In this triangle, I need the what? I'm going to use the CB together with this given side, right? I hope it is clear to you all, right? I am going to use the BC because this BC is the same as what? As the BF, right? I'm going to use the side BC and another side that is just given here, and I am seeing that the side that I am given here, it is only CA, right? I'm going to apply the sine rule here. What must come first when I am using all those listed rules, area rule, sine rule, and cosine rule? I must use the sine rule as my first approach, okay? The first approach must be the sine rule unless if it is stated otherwise. You must go for the cos rule if your expression it is involving the surd form or the squaring part there. It is where you can consider the cosine rule. But in this case, you need just to use sine rule, unless if it is stated otherwise, to calculate the area rule or to use cosine rule. I am going to use the cosine rule here, in which triangle I am going to use in triangle, which is this ABC. In triangle ABC, I'm going to apply the cosine rule, right? But you might be asking yourself that how, because we are not given all the angles, we can able to calculate this angle, right? Using the summation of interior angle of a triangle, right? Remember that that angle is going to be what? It is going to be 180 minus theta plus the beta. This angle, right? This angle here, it is 180 minus alpha plus the beta. So when I solve this, I am going to say the sine angle, which is B. Remember that this correspond with this correspond with this one. So I'm going to use the angle which is the sine B, the one that we just calculated, which is 180 minus this alpha plus the beta. Okay, then divided by the side, which is the what? AC, denoted as the small letter b, equal to another one. I'm using the sine angle A, which is denoted as the alpha, divided by the side, which is the BC. So instead of writing the BC, I will write the BF, right? Because I want to link this triangle together with the previous one. So I'm going to write the what? The BF. After that, I just have to do what? To cross multiply and make this DF subject to the formula here. So I'm going to have the BF multiplied by sine into 180 minus given angle. We find it on our what? On our second quadrant, whereby the sign it is positive. So when we simplify this further, it's going to give us sine into alpha plus beta equal to B multiplied by sine of our alpha. So I have to divide both sides by this as sine into alpha plus beta, sine alpha plus the beta, so that this and this cancel out. I left with the BF equals to B multiplied by sine of alpha divided by sine into alpha plus beta. I am not yet done, right? Because I have to express this DE in terms of this. So what I have to do here now, I need to substitute this BF to my first equation, right, for DE. Then I'll be done. This equation DE, I'm going to write this DE, it is equals to, so sorry for that, DE, it is equals to, where there's BF, I'm substituting the whole of this, B multiplied by sine into alpha, everything divided by sine into alpha plus beta, then everything divided by what? By cos of theta. Then I just simplify. I have to simplify this further. It's the same as B multiplied by sine of alpha, everything divided by sine into alpha plus beta, then multiplied by 1 over cos of this. I hope you will agree with me here, colleagues, that this is the same as this, right? So let me continue. Then this finally is going to be B sine of alpha divided by sine into alpha plus beta multiplied by cos of theta. This would be my final answer here, right? 5 marks for this. You can see that what we are getting here, it is the same as what we given in 4.3.2. D is the B sine alpha divided by the sine alpha, sine into alpha plus beta multiplied by cos of theta. Share, guys, just enjoy the video. There. Do not forget to hit the subscribe button, right, if you are glad about my presentation, so that you can keep updated with many more videos that I'm still going to upload.